So welcome back everyone. This is going to be another lecture where we are going to start with the risk management chapter. See, in this chapter we are going to learn how to manage risk. Okay. Besides that, there are two major concepts that we are going to learn in this chapter, which is VAR and Z-score. So the first one will be Z-score. Based on the Z-score formula, we are going to derive the formula for VAR. And VAR is the major concept in this entire lecture. Just give me a second. We are going to learn solve most of the questions for VAR in the chapter. There are 14 questions, out of which we will first solve the 14th question and then we will solve rest of the questions. There will be some homework which are of repetitive nature. But in order to understand the Z-score, see, VAR will be dependent on the Z-score concept. And in order to understand the Z-score, we will have to understand Z-table, standard deviation and mean. And in order to understand Z-table, you will have to first understand normal probability distribution. And along with this, these three concepts. So we are going to start from the very first, that is confidence interval, then confidence level, then level of significance. First, we are going to learn about these three concepts, just a basic understanding about it. Then we are going to learn about these three concepts. Then we are going to use this in Z table along with that, and then we are going to understand or derive the formula for these two last concepts, which will be useful in the coming questions. So ultimate objective is to understand this. Syllabus is this, Z-score and VAR. Rest of the part is not covered separately in the institute's module, but we are going to understand those in order to have a good clarity on the main concepts. Okay, so let's first come over to the example. Let me take an example of India's population. Now, if you will just have an idea, the entire population constitutes around 140 crore people in India. Out of that 140 crore people, if we want to calculate the average height of all the population, that is 140 crore, don't you think it will be very difficult for us? Exactly, sir, it is going to be difficult, because calculating the height of every person, then totaling those height, dividing it by 140 crore, and then coming to the average height seems little difficult, because finding everyone in the every corner of the country, then requesting them to come for the height measurement camp is very difficult. So now what happens is, if you want to calculate the average height of the India's population, what you are going to do, there is a concept called as sampling. When it is very difficult to take entire population, to do the research on entire population, what you do is you take the sample from that population. So what we are going to do, we are going to pick few people from every city, every state, and then we are going to do that research on the sample. So instead of calculating the height of every person in 140 crore, what we are going to do, we are going to just pick up 14 lakh people. And we can do this process of calculating the height on 14 lakh people. If Pradhan Mantri Narendra Modi ji gives us such instructions, then calculating the height of 14 lakh people won't be a difficult task. But yes, for 140 crore people, it is a difficult task. So suppose you calculate the height of every person in that sample, that is 14 lakh per heights. Then you do the total of all those heights divided by 14 lakhs. You will come up with the average height of a person. Okay, that average height will be called as sample average height. The main criteria is the sample that you have taken for the average calculation should represent the entire population. What I want to say from this statement is that you should not skip any city or major city or any state Let's say for example you are taking the sample and you have skipped entirely the East India states or South Indian states or North Indian states. That is not going to work out. You have to pick people from every state, every city in the sample as well, so that the result that you are going to come up with will represent the entire population. Okay, so I will assume that the sample that you have taken represents the entire population, and then you have calculated the average sample height. This average sample height can be called as the average height of the entire population. Because sample represents the entire population, the average sample height also represents the entire population. So we can say that at that time that 4 point, let's say 5.7 feet is the average height of every person in the country, average. Okay, why I'm taking such an example, I will just let you know. Now let's say for example you have measured the height of every person this way. Someone is of 6 feet, someone is of 5 feet 3 inches, someone is of 5 feet 9 inches, then 6 feet 2 inches, and so on, so on, and so on. Okay, then what you do is you calculate a range, not just one figure but a range, and you will understand that how many bars are there in this example? 1 2 3 4 5 6 7 8 9 10. Okay, so the example that is being represented in front of you have 10 results, out of which 9 results or the height of the 9 people falls under this category. So if you will see, the average, the range is 6.2 to 5.3. What do I want to say about this is, what I want to say with this 6.2 to 5.3 is the maximum height is 6.2 and the minimum height is 5.3. Means 9 out of 10 people fall under this category. Let me write it in a correct manner, 5.3 to 6.2. This is the minimum height, this is the maximum height, this is going to be the range. 90% of the chance, 90% is the probability out of the data that if you pick anyone and calculate the height of that person, it will fall under that range, 5.3 to 6.2. Are you getting it? Only 10% chances are there that you will pick this person whose height is less than 5.3, whose height is beyond that range. Otherwise 90% are the chances that anyone who you are going to pick will fall under that category. This 5.3 to 6.2 is called as confidence interval. This is your first concept. This is range. That 90% that you referred there, that 90% probability is that everyone will fall in that category. This is called as confidence level. And the opposite of the confidence level is called as level of significance, which is 10%. Now, what was the range? 5.3 to 6.2. And 90% chances are there that anyone whom you will pick and calculate the height will fall under this category. That means 10% are the chances that it will not fall under that category. So there will be rejection that you will face to this extent. 10% will give you opposite answer, the answer which is not favorable to you. So are you getting what is confidence level, what is level of significance, and what is confidence interval? These three concepts have been completed. Okay, 90% this confidence level will give you favorable answers, and this will give you non-favorable answers. Cool. Total should be 100%. The total of confidence level and level of significance should be 100%. Also, level of significance is denoted by alpha. So how you will denote the confidence level? The total should be 1. 100% means ones. So confidence level will be denoted by 1 minus alpha. So 1 minus alpha will give you 1. Okay. Sorry, plus alpha will give you 1. The total of both. That's okay. That is for statistical purpose only. Now come to the fourth point, which is normal probability distribution. Let me give you some examples about it. Yeah, this is the range confidence interval 5.3 to 6.2, and I'm 90% confident that okay, just Let me start it again. Yeah. So this is the confidence interval. This is the range 5.3 to 6.2, and I'm 90% confident that anyone whom you will pick will fall under this category. So this is giving you acceptance level and this is giving you rejection level. 10% are the chances that someone whose height is being calculated will not fall under this category. So he might be somewhere here or here beyond this category. So this is confidence level, level of significance and confidence interval. Now let's go to the next concept, normal probability distribution. Now any data, if said that it represent normal probability and normal distribution, it means the diagram of that data will look like this, the bell-shaped curve. I will give you some real life example about it. Let's take this desert. If you will see, there are some diagrams or some form that the sand has taken. You can clearly see that it is in bell-shaped curve. Are you getting it? This is the real life example of the normal distribution. What do you mean by normal distribution? You pick that sand and you pick that sand in your hand and then you drop it from a particular height. You will realize that at the same position, you will realize that the maximum sand will be collected exactly below your hand, means at the center, and then it gets normally distributed on both the sides, left and right side. So the maximum proportion of that sand will be found at the center. At the center. This is bell-shaped curve. This is a real life example. If you have seen a truck unloading the sand at any construction site, you will get an idea of normal distribution. The design or the shape that the sand will take after being unloaded from the truck will be a bell-shaped curve, and it will keep on spreading. So there is no limit. There is no limit. You will understand that this will never touch the x-axis. It will always be like this. It will never touch the x-axis, this line. Okay, so this is what the normal distribution is. Normal distribution. The next thing is the maximum proportion of this data. You can say sand, or you can take another example. Let's say we take the example of a garbage. You will see a normal distribution probability curve here, or we can say bell-shaped curve here as well. If you see, if you look at the truck unloading the garbage at any place, it will form a shape like this. That is normal. That is normal. That's why it says normal distribution. The entire garbage has been distributed normally from the center to both the sides, that is left and right side. So ultimately what happens is a bell-shaped curve is formed. Okay, so now you have understood about the normal distribution. I will talk about the probability in a while. Now under this curve, there are few things that you need to understand. The center, exact center of that bell-shaped curve is called as mean. The exact center of that bell-shaped curve is called as mean, and it is denoted by mu. This is the symbol. And it has been observed that after doing so many research on real life things, it has been observed that from that mean, 50% of the area constitutes on the left side and the right side also constitutes the same percentage. Means half of the garbage will be seen, we can be seen on the right side and half can be seen on the left side, and this is obvious because we are saying this is a normal distribution. So equal distribution will happen on both the sides most of the time. So total area means the total garbage. Let's say if it is 100%, then you will find 50% of the garbage on the left side of the mean and 50% of the garbage on the right side of the mean. That's why we call it as a mean. This is the center of both. So 50% area will be covered on the left, 50% area will be covered on the right. Okay, this is called as mean. After that, this is the example. Now I'll take another example. So this is a bell-shaped curve, and this is, you can clearly see, mean is here. Now one more thing which has been observed, that if you go one step, means if you deviate yourself from the mean, from the center, from the mean, if you deviate yourself for one step, you will find that, and it has been observed in many cases. Let's say we take the example of garbage, then this much of the percentage, 1, 2, 3, and 4. Let's do the total of all those 4, left and right side. So left side is 15 plus 19.1, that is around 34.1%, and this is also 34.1%. The total area is 68.2%. What does that mean? It has been observed that, it has been concluded after observing lots of real life examples, that the 68.2% of the total garbage can be found one step from the mean on both the sides. 34.1% on this side, 34.1% on this side. This one step is called as standard deviation. Why it is called as standard deviation? Because we are deviating from the mean. We are going away from the mean. So if you go one step away from the mean, I will call it as one standard deviation away from the mean. On the right side, you will cover 34.1% of the garbage, the total garbage. The total area is 100%, and out of that 100%, maximum area will be, that is 68.2% area will be covered just one standard deviation away from the mean. So what we did is, same percentage was coming after observing thousands of real life example, and that's why we have made it a standard, that it will be applicable everywhere. This is why it is called as a standard. Okay, now if we go one more step away from the mean, -1 to 2, and here, then you found that this much of the area will be covered 2 steps from the mean. How much? Let's do the total. We will add 4.4 and 9.2 as well now. 4.4 plus 9.2 plus 34.1. So 47.7, just a second, 47.7% on this side, 47.7% on this side. The total area will be somewhere around 95.4%. Means out of 100%, 95.4% of the entire garbage can be found 2 steps away from the mean. That is 2 standard deviation away from the mean. Okay. If we go further one step, let's go with 3 standard deviation. One more standard deviation on both the sides. Then we found that almost 99% of the total garbage can be found 3 steps away from the mean. Let's do the total. It will be 1.7 and 0.5%. 1.7, 0.5, 47.7. So that's around 49.9% on the left, 49.9% on the right. The totaling, it totals to 99.8%. What does that mean? That if we move three standard deviation away from the mean on both the sides, we will cover 99.80% of the garbage in that area, in that much of the area. So if you take the garbage example, same figures will apply. If you take the sand example, same figures will apply. If you take any other example which is normally distributed, the assumption is the data should be normally distributed. If the data is normally distributed, all these figures will apply to it also. So there are 2-3 things that we have seen. Normal probability distribution, probabilities means 99%, 68% and so on, 95%. Mean means the center of that, the mu, and standard deviation means on both the sides, how much we go on both the sides. If you remember the concept of standard deviation in the last lecture, I told you that standard deviation itself means how much we are deviating on both the sides, the upper side also and the lower side also. So in this case also the right side also and the left side as well. Okay. Now comes the 7th topic, which is Z table. See, you just saw that diagram, right? And let me ask you a few things. See, it is very easy for us now to remember the probability of the entire population, or the percentage of the entire population covered if we move 1 standard deviation away, that was somewhere around 68%, 2 standard deviation away 95%, 3 standard deviation away 99%. That's very easy. But tell me one thing, what is the probability or the percentage or area covered if we move 1.8 standard deviation away from the mean, and that too only on the left side, or 1.8 per standard deviation away on both the sides? What will be the probability or area? At that time it is very difficult for us to calculate from this graph, and that's where we have already made, or we can say the scientists, not the scientists, the mathematicians and every statistical people in the past have already prepared a table for that, which constitutes the figures of every minute or every small point. So if you want to calculate the area covered under 1.8 or 1.8788 or 1.90 or 1.91, every figure will be found in that table. It is very difficult from this diagram to calculate that, right? But we can find it out in that table, and that table is called as Z table. Okay, so let's now have a look on the Z table. This is the Z table. Okay, let's first go on the website. See, there is one website, if you are interested or if you have time, you can go to this website, Maths is Fun. You will see that I can just move my cursor to any point and I can get the area covered. So have a look on this. If I move just to the right side of the mean, this is the mean, right? This is the mean, or I can say this is the mean. Okay, so if we want to calculate all the area of the right side, that is 3 standard deviation away, so it will be somewhere around 50%. And if you want to calculate all the area of the left side, it will also be somewhere around 50%. It is not exactly 50%. Why? Because this bell-shaped curve never touches this horizontal line, so the area keeps on spreading and spreading and spreading and spreading. Okay, now if we want to calculate the area of garbage covered, understand, area of garbage covered, just 0.49 steps or 0.49 standard deviation on the left of the mean, it will be 18.79%. However, the same applies to the right of the mean, because both the sides have equal area covered. So if instead of minus 0.49 or left side, if I take plus 49, just give me a second, it also gives the same answer. For positive 49, it is 18.79. And for negative also it is 18.79. That means one thing is very clear, sir. If you are calculating the value for 0.49, it can also be applied for minus 0.49. Positive sign indicates the right side or the right side area, negative sign indicates the left area. Very clear? It was 18.79% and it is 18.79%. So if you want to calculate the garbage lying 0.49 standard deviation away from the mean on the left, it is 18.79. I will just write it here. 0.49 standard deviation away from mean on right. On right side, this is the example. Positive 0.49. If instead of right I write, if I want to calculate on the left side, this will be the example, minus 0.49. So the answer will remain same, that is 18.79%. The figure will change its sign. So if you want to calculate the area on the left, put negative sign here. If you want to calculate the area on the right, put positive sign here. The positive sign and the negative sign will indicate, please understand, will indicate on which side, on which area you want to, or on which direction you want to calculate the area. Cool. But let me tell you another, let me ask you another question. If I want to calculate the entire area from, let me just take the screenshot of this, because it will not I think give us the cumulative figure. 0 to z, okay, up to z onwards, right? Now let's take 0.49. See, now for the 0.49 deviation, the probability or the area which is shown here is different. It is 68.79%. Now what is the difference in the previous figure? 0.49, it is 68.79%. Earlier when we found this area, it was 18.79 and now it is showing 68.79. Why it is like that? Because earlier we were finding standard deviation of 0.49 from the mean to the left side. So it was 0 to z at that time. See, it was 0 to z, 0.49. When we go from mean, 0 means the mean, okay? Standard deviation at mean is 0. So 0 to mean is 18.79. But if you take the entire right side from 0.49, let's take 0.49, and if you want to calculate the entire area of the right side, then what you will do? What you will have to do is, you will have to take this 18.79% and also the rest of the 50% of the right side and add it. It will give you 68.79%. It's very simple. This is, if the table shows you 68.79 for this figure, we will call it as cumulative table. Cumulative itself means the entire area on the right side and not just till 0 or the mean. If you want to calculate till mean only, that is one tail, one direction. If you want to calculate the entire area, that is both the tails. So this represents only one tail to the left. This is called as, see, I will write down here, z table, yeah, or we can say if the z score is minus 0.49, we will say one tail to the left, because it is negative. If it is 0.49, it will also be called as one tail to the right. At that time the answer will be 18.79%, 18.79%. But if the answer is 68.79%, or if you want to calculate the entire population, entire area on the right side, you will have to write down minus 0.49 and 2 tail, not just the 2 tail, you will have to write down cumulative area. At that time it is deemed that minus sign will represent the left. So 0.49 right side from the 0.49 will represent 68.79%, like this, 68.79%. and if you will write down like this minus 0.49, then it will be rest of the area 31.21%. So positive sign will indicate the area on right side, negative sign will indicate the area on the left side of 0.49. So please understand now, if you look at the cumulative table and at 0.49, if you stand at 0.49, all the right side area will be represented in a positive figure and all the left side area will be represented in a negative figure. So if you write down 0.49 only, the area is 68.79. if you write down minus 0.49 means the left of the area, it will be 31.21. okay, this is enough. I hope you have understood. Now let's take the table values. See, this is the table, this is the standard table which has been made, and the table that I am showing you is a cumulative table. What do you mean by cumulative table? When the cumulative table is given, and if you are calculating the probability at any point of time, it will show the entire population on the other side as well. So it directly starts with 0.5. At 0 level it starts with 0.5, means if you are starting from this point, it has already taken this figure into consideration, so it will always add 0.5 to the rest of the area. Or if we take normal table, not the cumulative one, then this 0 will start from 0 only. You can see it here. At that time it does not take the entire 50% of the other side. Okay, that's cool. Now let's find out some basic figures. 0.65. See, if you go one standard deviation away, the cumulative figure is 0.8413. Cumulative is 0.8413 means, let's say we go it here at that, or let's say we go here. Am I right? 8413, and it shows, okay, 84 exact one. Now we should reach at 8413. See, so 84.13% is the entire area on the right side if we take z as minus 1. 8413. Sir, this is not minus 1. I just told you that the minus, the values of positive can also be applied to the negatives as well. It's just that you have to understand the concept of left and right side. If it is positive, it will represent the right side. If it is negative, it will represent the left side. Okay. So 84.13%. But if you will see this one here, this is the standard deviation. The standard deviation, the probability or the area covered is 0.3413 only. Why 0.3413? Because the table that I am showing in this page considers the values from mean. You can see 34.13. But if you consider the cumulative values for the same z-score, it will show you the total area. Now understand the difference. This much area, this much area, this much area, this much area. What is the difference between that? Cumulative figure covers entire area and non-cumulative one covers the area from the mean only. That's okay. Cool. So we'll take an example, then we'll understand what does that mean. But now let's move ahead. We have understood the table also, z table. Now once again we will go. There can be different types of table. This table that I'm showing you here is a cumulative table, and this table which is written over here is a non-cumulative table. It represents only single side. Okay. Only one tell. This is called as one tell. Okay. In the horizontal bar, the first row, and this vertical column, the first column and the first row is called as the standard deviation. These are the standard deviation that you want to go away from the mean, and the figures written inside those two, inside the standard deviation, are called as the area or the probability. So these are the probabilities. Total probability will always be 1. I will just show you here. It will always be 1. You can clearly see it here. The maximum that the values can go is 1. That is 100%. Okay, clear. So you have understood the concept of Z table also. Okay, let's take an exercise. Let's find out the value of 1.2 standard deviation, or the area covered under 1.2 standard deviation. So first we will go to 1.2, and this is the area, 88.49%. Now if we want to find out 1.25, the area covered under 1.25 standard deviation, then what will happen? We will find out 1.2 here, and we will find out 0.05 here, 1.25. So 1.2 here, 1.2 here. You will see this is the value. I will just remove it so that we can have a clear picture on that. 0.8944. That means 89.44% of the probability or the area is covered 1.25 standard deviation away from the mean. 1.25 standard deviation away from the mean means it considers the rest of the side as well. 1.25. Let's do the calculation here. See, 89.44% of the area on the left, up to Z onwards. So these are the three ways in which you can calculate the probabilities. Z means the figure that we want. Z means the Z score. That 1.25 is called as the Z score that we want to find out. See, at the end of the day, you need to understand few things in this. This is called as Z score. This is called as the probability. Somewhere it is called as the area. This is called as mu, means mean. And this 1, 2, 3, or you can say 1, 2, 3 are called as standard deviation. How far you are going from the mean. So these are the four things that you need to understand. With this, we will end our discussion of Z table. So you are clear with confidence interval, confidence level, level of significance, normal probability distribution, mean, standard deviation, and Z table. Now we are going to use all these things in the next concept, which is called as Z score, or the VAR after that. But we are going to understand it with an example. Have a look. Let's say, for example, we will draw a bell-shaped curve, a normally distributed data. You can draw a bell-shaped here if you want. Let's start with a mean. That means the amount of money that I already have in my hand. Let's start it from 30. And every coin that I add in my pocket, let's say it is of a similar currency. It is of the same currency, that is 10 rupee coin. Let's say, for example, that if I add one coin to my pocket, the total will be 40. If I add one more coin, it will be 50. If I add one more coin, it will be 60. But if I remove or take out one coin from what I already had, my total will go to 20, then 10, and then 0. One coin, every time I remove a one coin, I will lose 10 rupees from what I already have. But if I add one coin, every time it will add up to 10 rupees. Okay, this is the scenario. Now, if we think from the bell-shaped angle, this is the mean to us. Okay. Now, what I want to say is, let's just take out some example. How many coins are required? How many coins are required in order to make the total to 50? It's very simple example. If I want the total in my pocket to be 50 rupees, how many coins I will have to add up? And you can easily answer this question that, sir, if you want 50 rupees in your pocket and if you have already 30 rupees, then that means you have to add how much? 20 rupees in your pocket. And you just said that every coin is of 10 rupee. That means 20 divided by 10, 2. 2 is the answer. Two more coins have to be added in this pocket in order to take the total to 50 rupees. And that's what the z-score is, 2. That's what the z-score is, 2. So let me take the example, write it down here. Number of coins required to make the total to 50. So how did we calculate that? 50 minus 30. The first thing that we did is how much extra is required. 20 rupees extra is required. We wanted to reach to 50. And we are starting from 30 itself. This is the point from where we are starting, right? And if we want to reach out to 50, then that means we have to add 20 more rupees, and every coin is of 10 rupees. So it will be 20 divided by 10. I will just do it here. It will be 20 divided by 10 is equal to 2. That is the z-score. Now, can you create a formula for z-score? Yes, sir. Z-score is equal to in our bell-shaped curve example, the mean is denoted by mu, and every equal distance is denoted by standard deviation, which in this case is 10 rupees coin. Every distance from the previous one is of 10 rupees, right? In this case. And that is what we call it as a standard deviation in bell-shaped curve. There are two things that we learn in a normal probability distribution example, that is mu and standard deviation. So let's take 50. This is where we want to reach. So we will take it as x. X is the point where we want to reach, minus mu from the point where we are starting, divided by standard deviation. That's the easiest formula. X will give you the figure where you want to be. Mu will give you the figure from where you are starting. X minus mu. Understand the logic now. Don't just mug up the formula. X minus mu will give you the figure, the additional amount that you want to add up to mu. The difference between these two. And then standard deviation is the figure which will tell you how many steps you have to move away. How many steps you have to move away from the mean in order to arrive at x. So can I say that from 30 I have to jump 1 step and 2 steps. 1 step and 2 steps. That means from 30 I have to go 2 standard deviation on the right side to reach to 50. Why right side? Because the 2 here is positive. If there is no symbol, we will call it as positive. So we will say we want to go to right side. But let me take the same example. Instead of 50, if I want to reach out to 10 rupees, then what I am going to do? I will just write down 10 means the x that I want to be, where I want to be, mu from where I am starting, and standard deviation. That means the coin, every coin. the answer will be minus 20 by 10. The answer will be minus 2. Now in this case, when the answer is minus, when the answer is in negative point, that means you have to go left from the mean. So we will go left from the mean. Do you understand this? Left, 2 steps left from the mean. This is what the z-score is. That means if we compare this example with the normal probability example that we that with the standard deviation diagram, in that we can call 30 as 0, 20 as minus 1, 10 as minus 2, 0 as minus 3, 40 as 1, 50 as 2, 60 as 3. It's very simple. Are you getting it? So this is your entire example. Now what we are going to do, we are going to solve some questions based on the z-score formula, and then we will get to know that how to use that. Okay, let me take up some example. Now since you have understood that you need to move 2 standard deviation on the right side, can you tell me the probability of that point? This on your table, the table that you will get in the exam, or you have the standard table that is used by everyone in the market, the probabilities will be given are for the standard deviation, right? Not for the coins or rupees or anything like this. They are for the standard deviation 0, 1, 2, 3, 0, 1, 2, 3 on this side. Now, if I want to say what is the probability that my answer will be, please understand, what is the probability that my answer will be at least 2, the z-score. That means at least means I want 2 or more than 2. That means I want to cover up this entire region. And now one more thing. What is the probability of my answer will be 2, at least 2, is similar to or equivalent to the probability of me having at least 50 rupees, because this diagram is being converted to this diagram. Now on the basis of this diagram, we are going to find out the probability of at least 2, and then we are going to apply the same probability to at least 50. Now understand the meaning what I'm saying. In the Z table, you will not have such figures like 40, 50, 60. So any question which is being asked in the exam, you will have to first convert that diagram into the basic and the standard diagram of 1, 2, 3 standard deviation. Now find out that if we want at least 50, then what is the equivalent z-score value of that in this diagram? For 50, 2 is the equivalent z-score value. For 50, 2 was the equivalent z-score value. Means the probability of at least 2 can be applied to the probability of at least 15. If you go to the diagram here, and if you will see that the probability of at least 2 comes to 0.9773. Instead of that, we will just find out here single table, not the cumulative one. We will just take the answer from here. This will give us at least 2. This is not at least 2. First of all, please understand, we want at least 2 means 2 and more than 2. That means the right side of the table. So Z onwards. See, Z onwards. This is the direction. Do you want up to Z or beyond Z? We want beyond Z. Z onwards. So that is 2.28%. That is 2.28%. That much only. How to calculate that? It will be given here. The table is not given here. This table that is being shown here gives the data of 0 to z values. Okay, the table that we have gives the data of up to z values. So we do not have the table of z onwards. Now I will tell you how to calculate 2.28 with the cumulative table. The probability of 2 is 0.9773. That 0.9773 is the entire left side value right now, because it is cumulative, it covers up the rest of the area. Okay, so it is, let me show you here, is 0.9773. It covers the entire left area. Why it covers the entire left area? Because you have taken it from the cumulative table. If you take the cumulative table, wherever at whichever point you are calculating the answer, it considers the rest of the 50% on the other side. So if we are calculating 2.28 on the right side, it covers the area from that point to the left side area, the other area. Okay, but it is very easy to calculate the area on the right. What you have to do is 1 minus 0.9773. 0.0227, that is 2.27%. This is the area on the right. Why? Because left plus right is equal to 1, and if you know the figure of the left side, it is very easy to calculate the figure of right side. 2.27%, that's it. It's very easy. So that is 2.28. Our answer is 2.27. Are you getting it? Please understand, the cumulative figure means it includes the other side as well. So in the cumulative table, if you calculate this point, it will give you the answer of this entire area. In the cumulative table, if you calculate this point, it will give you the answer of this entire area. So you can use it for right, for left, both. But understand, cumulative means it considers the rest of the 50% also, the 50% area on the other side as well. So when we are on the left side, the other side is right. When we are on the right side, the other side is left. Okay. Now what does that mean? This means that the area of having, or the probability of having at least 2, or the probability of having at least 50 rupees is 2.27%. That I will have 50 or more than 50. Rest of the probability is 97.73%. What does that mean? That my answer will be less than 2, or my answer will be less than 50. 97.73% is the probability that my answer will be less than 50. Now let's take up one example, question number 14 of our compiler, in order to find out how to use this formula. Question number 14. Have a look on this. We are going to use the formula that we have learned yet. ABC Limited is considering a project. Now ABC Limited wants to invest in a project which is normally distributed. Please understand, most of the students ignores these two words. They think that it is not relevant for the answer because it is not like some figure or something, but it is not like that. If it is normally distributed, immediately one thing should come in your mind, that this is going to form a bell-shaped curve and has a mean mu return of 2 crore with a standard deviation of 1.60 crore. Mean of 2 crore with a standard deviation of 1.60 crore. Immediately you should be able to draw it here. So let's say we take the mean as 2 crore. Return, this is our profit, and a standard deviation of 1.6 crore means if we move one step on the right, our total profit will grow to 3.6. One more step, it will grow to 5.2. One more step, it will grow to 3.6, 5.2, 6.8. Right. But if we go on the left side, that means instead of profit, if the losses happen, then 2 minus 1.6 will be 0.4 profit only. Here minus 1.2 will be the profit. That means we have started incurring losses, and minus 2.8 will be the losses. Most of the time we just have to think 3 standard deviations away from the mean. This is first standard deviation, second standard deviation, third standard deviation. This is first standard deviation, second standard deviation, third standard deviation. Okay. So if we write down here, mu is nothing but 2 crore in this case. Standard deviation is nothing but 1.6 crore in this case. Okay. Now, in case ABC Limited loses on any project more than 1 crore, it means that if the loss on any project is more than 1 crore, loses means loss, there will be financial difficulty. Now find out where do you think that 1 crore loss will lie. According to me, if we talk about the losses, it will lie somewhere at this point, because till this point I have a profit of 40 lakhs. Then the profit starts decreasing. Somewhere it goes to 0 lakhs, and then the negative profit, that means the losses will start increasing. Somewhere down the line here we will have 1 crore of the loss. So then 1.2 and then 2.8. So what I am going to do, I will just mark this point as 1 crore loss. This is our x. In the previous example, x was 50. In this example, x is minus 1. Okay, cool. This is our x, minus 1. If you write 1, that means it is a profit. If you write minus 1, that means it is loss. Now the question is, if we lose more than, now focus again on this word, more than 1 crore. Where do you think the more than 1 crore will lie? On the right side of this point or on the left side of this point? More than 1 crore of the loss will be covered on this side, because on that side the loss will be less than 1 crore and there will be profits after that. But more than 1 crore of the loss will lie on the left side. Now, the logic says that company will be in financial difficulties if the losses are more than 1 crore. Company will not be in the financial difficulties if the losses are less than 1 crore. It means that if the company's profit or loss are there anywhere on the right side of minus 1, then the company will not be in financial difficulty. Even though the loss, let's say for example, the loss is 0.6 crore negative. Let's say the loss is 60 lakhs. Although the loss is 60 lakhs, there will be no financial difficulty according to the statement given in the question. The financial difficulties will start for the company if the loss grows more than 1 crore. So that is the left side of this point. Okay. Now, determine the probability, the chances that the company will be in financial difficulty. Now, there are two probabilities that we can find out according to this diagram. We can find out the probability of company will be in the financial difficulty, company will not be in the financial difficulty. The question is asking us about the probability of this point. We are going to find out the probability of both the sides, so that next time the question comes in exam, you are very clear of which answers to write. We are going to find out the probability of probability that the company will not be in financial difficulty and company will be in the financial difficulty. Now let's go ahead. First of all, probabilities can be found on the Z table, right? Z table considers only basic and standard deviations. Standard deviation, that is 1 2 3 minus 1 2 3. So in order to do that, first we have to convert this diagram into a basic bell-shaped curve, a standard bell-shaped curve with 1 2 3 standard deviation. So let's do that. In the standard bell-shaped curve, mean starts from 0. Then comes the 1 standard deviation, 2 standard deviation and 3 standard deviation. On this side comes minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation. Okay. What we have to do is we have to find out the probability of the left side of -1 loss. But -1 is not -1 crore rupees of the loss is not something there on the table. So we have to find out the equivalent figure first of -1 crore. Means if we look at this table, what will be the position, what will be the number which is equivalent to -1 crore of the loss on this diagram? So it's very simple. We have to find out Z score. What is this 1, 2, 3 and all? Z score, standard deviation. We have to find out the standard deviation. Okay. How to do that? Z score is equal to the point where we want to reach is -1 crore of the loss. The point from where we are starting is the 2 crore of the profit. So if you will see how many crore of the loss that you will have to go on left side in order to reach at 1 crore of the loss, first there is profit of 2 crore. It will go down to 0. So you have to incur the losses of 2 crore just to reach at 0 profit loss. From that 0 to -1, 1 more crore of the loss has to be incurred. So 3 crore of the losses will give you -1 figure, 2 minus 3, right? Okay. It means that we have to suffer a loss of we have to suffer a loss of 3 crore, or we can say the profit of -3 crore. And every standard deviation is of 1.6 crore. Every step on the left side is of 1.6 crore. So if we do that, we will get the Z score. That's 1.875. Please understand what is this. This is the equivalent point on the standard table. That means on this table, on this diagram, the figure of -1 crore is equivalent to the figure of 1.875 score on this table. Both the table, if we equate both the table, -1 is equal to 1.875. Now you have to find out the probability of 1.875, the left side probability of 1.875. The same can be applied to -1 as well. Okay, so this is our answer. Now if you will find out in the here, standard normal distribution table score providing area between mean and z, mu and z. Please understand, this is very important. The areas given in this table is just between mu and z. That means the areas given to you, I will just do it with another pen, mean and z. This much of the areas are given only, and that will be sufficient. Let's first calculate the Z score of 1.875. Now you will see you have 1.87 and you have 1.88 given in the table. 1.87, 0.4693, 0.4699. 0.4693, 0.4699. If you do the average of these two, add both the figures and divide it by 2, you will get 1.875, which is the figure that you want. So we will do the average of these two as well. This is called as interpolation. You have to move equal points from every side. So what we are going to do, 0.4693 plus 0.4699 divided by 2. We are just calculating the average of these two. In the similar manner, we are calculating the average of 1.87 plus 1.88 divided by 2. It will give you 1.875. Then it will also give you the answer of 1.875. 0.4693, the middle figure of these two values. 0.4994. 4696, sorry. 4696. What is this 4696? 4696 is the probability of this area, 46.96%. That's it. Only this much area. But there is one good news. You already know the probability of entire right side, which is 50%. So if we take the entire right side, the total probability will be 96.96%. This is the probability that the company will not be in financial difficulty. 96.96%, because the same probabilities can be applied over here. So what I'm going to do in the 96.96% is the probability that the company will not be in financial difficulty. But we do not have to calculate the probability. We don't have to calculate the probability of not having financial difficulty. We have to calculate the probability as per the question that the company will be in financial difficulty. So financial difficulty probability will be 1 minus 0.9696, 0.0304, 3.04%. This much are the chances that company will have losses of more than 1 crore. At least 1 crore. At least 1 crore. That is the left side. In other terms, this 1 crore is nothing but VAR, value at risk, that we are going to study further. But let's come to the answer here. What we did first is we calculated the z-score. Now please understand this entire formula from your own perspective. Z-score is nothing but the equivalent standard deviation value on this normal table. We cannot use -1 and find out the value of that in the table now, because -1 crore is the figure of this question only. We have to find out the equivalent table value, that goes to -1.875. Am I right here? It was -1.875. Right, it was -1.875. See here, -3 divided by 1.6 goes to -1.875. Okay. So corresponding areas where 875 is coming is 87 and 88. Then we interpolated and we found the value of 0.4696. And we added that 0.4696 into with the entire probability of right side to come up with 96.96%. This is the probability that the company will not face any financial difficulty. But our question was, how much is the probability that the company will face the financial difficulty? What we did is we deducted 96.96% probability from 100% to arrive at 3.04%. This is your final answer. How this is difficult? This is not difficult, but understanding it is going to be difficult for the first time. So all in all, what we did, I will just summarize here once again. Because the question said that the data is normally distributed, we calculated, or we draw a diagram for that, and it was looking like this. The mean started from here and it went up to 3.6, 5.2, 6.8, 0.4 minus 1.2 minus 2.8. Now the question said that calculate the probability that the loss will be at least 1 crore or more. That means this area. But we do not have such kind of table where our profit and losses are given. We have a standard table in the market. We have a standard table. If we compare the standard table with our example, then 2 will be the mean, which is 0 in our standard table. Then 1, 2, 3 standard deviations are there. It is like this. Because both sand and garbage examples are normally distributed, the probabilities of this example will apply to this, probabilities of this example will apply to this for the same location. Now what we did is, instead of finding the probability of 1 crore here, 1 crore loss here, we found the equivalent value of z-score on this line, and it was minus 1.875. So we thought that if we calculate the probability of minus 1.875, it can be applicable to -1 in this case as well. So we started finding the probability of this. Now please understand that the question gave us the probabilities of z-score, probabilities between z-score and mean only. Z-score and mean only, this much area. Or you can say if we take 1.875 here, it will be like this much area. The same can be applied to the other side as well. So what we did, we found the probability of 46.96% of this much area, but we didn't want to calculate that. We wanted to calculate the probability of left side. Okay, so what we did is, there are two ways, understand. This much of the area constitutes 50%, this much of the area constitutes 50%. So if you will find the answer in the compiler, what they did is, they just deducted 50% from 46 point, they just deducted 46.96% from 50% to arrive at this side, this particular probability. This can also be done. What we did is, we added 50% first to make it 96.96%, which constitutes this much of the area, 96.96%. And this much of the area, if it is financial difficulty area, this is no financial difficulty area. And then we deducted this value from 100% to arrive at 3.04%. In both the cases, it will give you the same answer. But just to make you understand that what is the probability of no financial difficulty, we added 50% in that. It's very simple. If more examples are coming in exam, you should be able to solve it very easily. If you have any kind of a doubt, you can feel free to ask me in the Telegram channel. Now we are going to come over to the last concept, which is value at risk. Let me take a break of 2 minutes and then I will be back with the value at risk. So hi guys, welcome back after the break. Now we are going to discuss over the last concept, which is VAR, value at risk. So first we are going to understand the concept of VAR, then we are going to derive the formula of VAR using the formula of z-score, and then we are going to solve lots of questions in the next lecture using this formula of VAR. Okay, so are you ready? Just be with me for another half an hour to understand the concept and the formula of the VAR. What is more important in this chapter? The chapter's name is risk management. Do you understand that? The chapter's name is risk management, but before management of the risk, the more important part is to measure the risk. Before you know the amount of risk, how you will be able to manage the risk, right? So you need to quantify it before taking some action in order to reduce that risk. So risk measurement, there is one concept in the previous lecture that we learned about risk measurement, that is volatility. In other terms, we used to call it as a standard deviation, sigma. This is the most popular and traditional measure of risk, which is volatility. But standard deviation has some drawbacks. Now, what is the problem with the standard deviation? Let's discuss that. The problem with the volatility is, it does not care about the direction of an investment's movement. It shows profit as well as losses. Now, if you remember, in the standard deviation concept, I told you that if our expected return is 10% and the standard deviation is 2%, then our return can go up by 2% to 12% and down by 2% to 8%. So standard deviation shows the movement on both the direction, the above upside also and the downside also. So it shows the profit side as well, the loss side as well. But tell me one thing. Do you really think investor cares equally about the profit and loss? No. Before taking investment decision, the one thing that is most important for the investor is to know about the chances of losing money. He is not that much worried about the profit. How much will be the profit? If there is profit, then it's okay. But he is not equally worried about both the two. He is more worried about the losses than profit. So more important among the two is to know about the loss only, not the profit. That's why standard deviation and volatility will not give you the correct figure, the proper answer. We need one concept which only talks about losses, and that is nothing but the VAR. VAR answers the question, what is my worst case scenario? It shows loss side. How much could I lose in a really bad month? VAR means how much of the value of your investment is at risk. VAR. So let's take an example. Suppose an investor invests around 20 lakhs in a single asset over a 1 day period. For just 1 day, he is investing 20 lakh rupees. And if I say that his VAR means the value at risk is 1,72,400 at 99% confidence interval or confidence level in this case. What does that mean and how to interpret it? Out of 20 lakh rupees of the investment, I am 99% confident. I am 99% confident that my loss will not go beyond 172,400. My loss will be in a range or below 172,400. I am 99% confident. So 99% confidence level shows the favorable side for the investor. Favorable side is lesser loss. But at the same time, it means that there is 1% chance. There is 1% chance that your loss may go beyond 172,400 or at least 172,400. So your loss can be anywhere here. 99% talks about 172,400. 1% also talks about 172,400. So when you consider 99% or 1%, the figure is not important. The important is the wording before that. Maximum 172,400 or at least 172,400. So when you say maximum 172,400, that means your loss will be below 172,400 and you are 99% confident about it. But at least 172,400 means the loss will be 172,400 and beyond that, and the chances of happening of that event is 1%. So are you getting it? The meaning of VAR. VAR is 172,400. That's okay. That's not an issue. You can lose 172,400 in a single day. But another interpretation is like you are 99% confident that the maximum loss will be 172,400. It can be below that. You can also lose only 2 rupees. That is covered under 99%. You can earn 10 rupees. That is also covered under 99% because it says the maximum loss is 172,400 and below that there will be lesser losses and then profit will be there on that side. So profit is also covered in this area. Another way to talk about it is only 1% chance that your loss will go beyond 172,400. So you understood the concept of confidence interval, confidence level here. Then significance level. This 1% is called as level of significance. If you remember, we discussed about this in the beginning. 172,400 is the VAR. Okay, 1 day is the time period. We will call it as T. And 20 lakh is the total investment. This is how we should read it. Now comes the formula of calculating 172,400. Now we are going to discuss about how to calculate 172,400. So have a look. What is the formula for VAR? Let me just go through it. This is the formula for VAR. VAR is equal to z-score multiplied by standard deviation. Now, if you don't go deep into the formula and understand the derivation of this, you will have to mug up this formula for the rest of your life till you clear CA final exam. Not just the rest of the life, till you clear CA final exams. You will have to mug up every time you see this formula. But once you understand the logic and the derivation of this formula, you will be very happy to know that this is not something new that you will have to understand. The previous formula of z-score will help you to calculate VAR, and in fact the z-score formula was also conceptual that we discussed earlier. So let's first derive this formula. Okay, so what we should do, I think we should understand the concept or the derivation of the formula with the help of first question that is covered in the syllabus in risk management chapter. So I would request you to come over to page number 1. I'm going to read this question, and what I'm going to do, I'm going to obviously solve this question, but before that, just taking up the figures from this question, we are going to understand the derivation of the formula. So let's read out first question. Keep the pen with you in order to mark the important things. Neil holds 1 crore rupees shares of XY Limited. So what do you understand by 1 crore rupees of the share? That is his investment. Okay. Whose market price standard deviation is 2%. Now, if you will look at this, this is standard deviation. 2% is standard deviation. Okay. If you calculate the 2% of 1 crore, it comes to around 2 lakh rupees. Cool. Assuming 252 trading days. Now, just understand. How many days are there in a year? 365. But if you will see, on an average, there are 52 weeks in a year. Okay. And every Saturday and Sunday, the market is closed. It is not open. So only 5 days a week, trading sessions are open. So if we multiply 52 into 5, we come up with trading sessions, that is 260 days. And out of that 260 days also, if Diwali is coming coming in between Monday to Friday, if some public holiday is coming in between Monday to Friday, those days will also be off. So reduce on an average 8 days. From 268 comes down to 252 trading days. So that is the logic of 252. Anywhere if you want to take trading days, then do not take 365. It should be 252 only. Okay. Then what we have to do is we have to cover up the maximum, calculate the maximum loss. It's not the at least part, it's the maximum part that we want to calculate over a period of 1 trading day and 10 trading days with 99% confidence level. So we want to know what should be the loss. Remember that 174,200 figure from the previous example? It was 174,200 in that. We have to calculate the same in this question. Cool. We just remove it. We are 99% confident that the loss will not go beyond this level. You have to calculate that level in this question. That is what the VAR is. That figure 174,200. Okay. Assuming share prices are normally distributed, just write down one word here which was missing. Normally distributed. It should be normally distributed for level of 99%. For a confidence level of 99%, the share prices are normally distributed. Means this entire investment is depicting a picture of normal distribution. Cool. So we can formulate that graph. The equivalent z-score, we'll just leave it to later. Now focus on this. Since the question clearly says that the figures are normally distributed, what we are going to do? We are going to draw a picture like this. Okay. So in the center exact mean, there will be, we will start with the profit or losses. Since we have just invested, we are going to take it as 0, because the moment you invest in the market, your profit or loss is 0. And from that point onwards, either it will be profit to you, it will be loss to you. The standard deviation of this profit and losses are given to you, which is 2 lakhs. You remember 1 crore multiplied by 2% is the standard deviation per day. Cool. So it can be either 2 lakh profit to you on the first day maximum, or 2 lakhs of loss to you, 4 lakhs, 4 lakhs, 6 lakhs, 6 lakhs. Chalo, great. Enough. Now we want to calculate that what is the amount of maximum loss where we are 90% confident. It means the area under the normal probability distribution should be not 99%. Cover up the area of 99% and tell me the figure of loss, that this is going to be the maximum loss. What should be the figure of loss where you will be 99% confident that the loss will not go beyond that. Now please understand one thing. First of all, they are talking about loss. That means they are talking about the area, the figure on the left side. Figure on the left side, because losses are there on the left side only. This is the profit side. Forget about it. Like think about this area. Okay. Now you want to find out a particular number of loss where you are confident that the loss won't go beyond that. Maximum means it will not go beyond that. It will be lesser than that. Okay. So, but you also know that the probabilities given in the table, in the Z table, are not for this profit or losses. It is for the standard format, which is like this. Where R mean is 0, here we write 1 standard deviation, 2 standard deviation, 3 standard deviation, minus 1, minus 2, minus 3. Now what we should do first is, we should find out 99% probability, the point of 99% probability, whether it comes to here or where. So let's go into the table and then find out where do we exactly land with a 99% probability. See, if I want to, I will just cover up here. The probability is 95.45. If I just increase the figure, I'm just getting closer to 99%. I will just do it again and again and again and again and again and again. I'm very close to it. 99.01. See, I have reached at a 99% probability, and I can see that the point at which we cover 99% probability is 2.33. 2.33 minus 2.33. You can also go to this point. In this case also you will have the same probability, 99%. But we are not worried about the profits, na? We are worried about the losses. So that's why we'll come on this side. So 2.33 is the figure where 99% probability is given. Now you don't have to worry about this because it is already given in the question, and it will be given most of the time. The equivalent Z-score from the normal table of cumulative area is 2.33. That is what is saying. That means on the normal table, 2.33 is the point where you can clearly say that we are 99% confident. Okay, great. So 2.33 comes down to this point. 2.33. Please understand. This entire area, in this entire area, we can say that we are 99% confident that the value won't go beyond 2.33, or the value will be maximum 2.33. This is normally distributed. This is also normally distributed. Means the probabilities or the areas or the locations of this graph or the figure will be applicable in a similar manner to this one also. Okay. So what we have to do at the end of the day is we have to calculate a straight line from this. Means we have to find out up this point, and this will be your VAR. This will show you the maximum loss, because these are losses. This figure will be the loss itself. This is the maximum loss, and the entire area beside this will be 99%. So you have already calculated the area. This is 99% area, and you are confident that, let's say for example, we take it as X. So you're confident that the loss won't go beyond X, and you're 99% confident in this case. How did you calculate that? You calculated by equating this entire diagram with the standard diagram. You wanted 99% probability, and that 99% probability is given in the standard diagram, not in the any diagram given in the question. So you equated first, you drew this particular standard deviation standard table. Then you found the 99% probability. Where does it lie? It lies at 2.33 z-score. This is z-score. .33. Okay, then you found you tried to find out the equivalent location in the above figure, because both of these are normally distributed, so this 99% can be applied to 99% here as well to this point. And now we have to calculate this. If you remember, this is nothing but the same example that we have taken in the previous example, the question. In that, our x was minus 1 crore, if you remember, and standard deviation was 1.6 crore, and we had to calculate z-score. But now z-score is given and we have to calculate the VAR or x. Now let's do that. So what is the formula for z-score? X minus mu divided by standard deviation. X is what you have to find out. Z-score is 2.33. Mu is 0 in our case, if you can see it here, 0. And standard deviation, how much is the standard deviation? 2 crore rupees of the loss on each side, profit or loss. So it is 2. So if you will find out, x is nothing but 2.33 into 2, which is nothing but 4.66. This is nothing but your VAR. Value at risk means 4.66 is the loss. 4.66 is the loss. Maximum loss 4.66 crore, where you are 99% confident that your loss won't go beyond 4.66. And this is the concept of VAR. How did you arrive at the formula of VAR? Please tell me. X is nothing but the VAR, right? Or we can just write it again, the formula. The formula of z-score is nothing but x minus mu divided by standard deviation. Z-score, x is nothing but the VAR that we wanted to calculate. Mu is always 0 because we'll start from 0 itself. And standard deviation, just write down SD. So the formula becomes like this: z-score is equal to VAR divided by SD. And if you send SD on that side, it will be VAR is equal to z-score multiplied by SD. Now you remember this formula. VAR is equal to z-score multiplied by SD. It is nothing but the same formula of z-score. Z-score is equal to x minus mu divided by standard deviation. This mu is altogether eliminated because it always starts from 0 while calculating VAR. Standard deviation is this figure, z is this figure, and x is this figure. So it is the same formula. You don't have to mug up anything. Chalo, cool. So in this question, VAR for 1 day is 4.66 crore. Let's come down to the compiler. You can clearly see first we calculated the volatility, that means standard deviation, which is 2 lakh. Okay. Then the maximum loss for 1 day at 99% confidence level is VAR 1 is equal to, let's write down the formula. Please write down the formula. Formula is not written in the answer, so you should write down the formula here. VAR is nothing but z-score multiplied by standard deviation. So z-score is 2.33, standard deviation is 2 lakhs. So 1 day is 4.66 lakhs. How to interpret this? In 1 day, the maximum that I will lose is 4.66 lakhs, not crore, sorry, it's lakhs. That is the maximum that I will lose, and I am 99% confident about it. Only 1% chances are there that my loss will go beyond 4.66 lakhs. Cool enough. Now comes the next question. This was the maximum loss in 1 day. The question is also asking you to calculate the maximum loss in 10 days. So it's very simple. This was the formula for VAR, okay? So what we are going to do, we are going to write down VAR for 1 day is equal to z-score multiplied by standard deviation for 1 day. Am I right? If we want to calculate VAR for 1 day, we are going to use the standard deviation for 1 day. The next thing which is given in the question is we have to calculate the VAR for 10 trading days as well. In 1 trading day, the maximum loss was 4.66 lakhs. not crore, lakhs. The question is also asking that if we keep that investment for 10 days, what will be the maximum loss in 10 days? We cannot just simply multiply 4.66 with 10. Getting it? Loss for 1 day is 4.66 lakhs, sir. What is the loss for 10 days? 46.6 lakhs. No, it is wrong. Because every other day, the chances are that your profile or your investment may go up and the losses can reduce. Standard deviation itself means standard deviation. We are using the standard deviation, right? It means it can go up and down as well. So in total, considering all the ups and downs, we have to conclude what is the maximum loss in 10 trading days. Okay, so let's come down to this formula. VAR for 1 day is equal to z-score into standard deviation for 1 day. That is what we used. Z-score was 2.33. Standard deviation for 1 day was 2. The answer was 4.66. This was the first answer, the VAR for 1 day. But if we want to calculate the VAR for 10 days, then the formula will be something like this: z-score into standard deviation for 10 days. Isn't it logical? Yes, sir. The base should be same. If we are calculating the VAR for 10 days, standard deviation should be used for 10 days. Cool. Now, how to calculate the standard deviation for 10 days? Because we have not been given this information in the question. The information which is given in the question is z-score and standard deviation of 1 day. How to calculate standard deviation of 10 days with the help of standard deviation of 1 day? Sir, simply multiply 2 lakhs with 10. No, this will give you the wrong answer again. Understand? If you multiply, there is one way. You can just do it like this: 2 into 10, 20 lakhs. This is wrong. If you are saying that standard deviation of 1 day should be multiplied with the time in order to arrive at standard deviation of 10 days, this is wrong. What is the proper formula? Sir, standard deviation of 1 day should be multiplied by square root of time in order to arrive at standard deviation of 10 day. So if we do that, 2 lakhs into square root of 10, we will come to a figure, let's say into 6.32 lakhs. So for 10 days, the standard deviation is 6.32 lakhs. Sir, what is the logic of not using t and using under root t while calculating the standard deviation for multiple days? I will just tell you in a minute. Do you know from where the standard deviation is calculated? Standard deviation is calculated with the help of variance. Standard deviation is denoted by this, and variance is nothing but the square of standard deviation. You know this concept because in the previous lecture we actually discussed how to calculate standard deviation. And while calculating the standard deviation, first we arrive at a formula of variance, and from variance, if we do the square root, we go to the standard deviation. So standard deviation does not have individual value of its own. It is derived from variance. So if you want to change something from 1 day to 10 day, don't change the standard deviation, change the variance, because this is the individual value. This is what I can say is that this value is derived from the past figures, not this. So you should change this. Now please understand, if you want to multiply it with time, if you want to convert standard deviation or variance of 1 day to 10 days, just multiply it with 10. You will arrive at standard deviation of 10 days. Let's do that. What is the standard deviation? It is 2 lakhs. So what will be the variance of it? It is 4 lakhs, 2 into 2. 4 multiplied by 10 will be 40. But this is still the variance. Variance multiplied by 10 will be the variance only. Variance of 1 day multiplied by 10 will be the variance of 10 days. So 40 is again the variance. Now what you need to do is just put a square root for this. Put a square root. We will arrive at standard deviation of 10 days is equal to square root of standard deviation or variance of 10 days. So it will be square root of 40, and 40 square root will give you the answer of 6.32, which is the same as this. So what I want to say is putting a square root with standard deviation is wrong. Sorry, putting time directly with the standard deviation is wrong, because standard deviation is derived from a figure called as variance. So if you want to multiply it with 10, multiply the variance with 10 and not the standard deviation. So yes, we will multiply the variance with time with 10 and we will arrive at this figure. Now what is the formula? What is the formula? Under root 40 is derived with this answer, 4 into 10. 4 is nothing but the variance of one day, and 10 is nothing but the time. Am I right? And this is standard deviation of 10 days. 40, no? Right. So you can clearly see this figure, this standard deviation one day has square in it and square root also. So square root will cancel the square function and the only thing remaining will be standard deviation of one day multiplied by t is still in under root form. T is still in under root form and it will be kept as it is. We have just bifurcated, or in another way I will just write it down. Have a look. We can write down this equation as two different under root equations. Standard deviation of one day square, or the variance of one day square root into under root t. We can write it like this. This first part can be easily converted into standard deviation of one day, as the square function will cancel the square root function and this will be kept as under root t. This is standard deviation of 10 days. That's it. This is the formula that you have to use in this question. So let's solve the VAR for 10 days. What I'm going to do, I'm going to put this formula for 10 days standard deviation in the above figure here at this point. Let's write it down. Standard deviation of 10 days is nothing but standard deviation of one day multiplied by under root t. Now let's put down the figures. 2.33 into 2 lakh is the standard deviation for one day into under root 10. Time is 10. So if you do the calculation, 2.33 into 2, or 10 square root into 2 into 2.33, you will arrive at a figure of 14.74 lakhs. This is the maximum that you will lose in 10 trading sessions and you are 99% confident about it. See, 14.74 lakhs, 99% confident about it. So ultimately that you learned is this formula. Please understand. VAR for one day is equal to standard deviation, or z score, multiplied by standard deviation for one day. If you have to calculate it for multiple days, you can write it like this. VAR for t days is equal to z score into standard, or let's say 10 day, we will just write it directly. VAR for 10 days is equal to z score multiplied by standard deviation of 10 days. And in order to convert standard deviation of 10 days, we can manipulate the formula z score into standard deviation of one day multiplied by under root t. Now observe something. This much of the formula and this much of the formula is same. So we can replace, instead of z score into standard deviation of one day, we can replace VAR of one day. So another and the third formula for this is VAR for 10 days is nothing but VAR for one day into under root t. So this is the first formula, second formula, third formula. In your question in the compiler, this formula has been used. And you can do it easily. Like, what was the VAR for one day? 4.66 into under root 10. 4.66 into 3.16. The answer is 14.74. Same answer. It may happen in the question in the exam that they will give you only VAR and under and time in order to calculate the 10 days VAR. They might not give you the standard deviation directly. They will not give you the z-score. Without z-score and standard deviation also you can calculate VAR with the help of this. VAR for 1 day into under root t will give you VAR for 10 days, means time for t days. Are you getting it? So you need to remember this formula. This much is very, very important. Very, very important. You can write it down here. This is nothing but under root t into VAR for 1 day, which has resulted into VAR for 10 days. So there are multiple formulas that you should remember. All the formulas should be written over here. VAR for 10 days is equal to z-score multiplied by standard deviation for 1 day. Sorry, 10 days. Then you convert the standard deviation of 10 day into standard deviation of 1 day into under root t, z into, and then you can convert this much part into VAR of 1 day into under root t. So there are 3 different formulas for this. Have you understood the concept of VAR first of all? Yes sir, we have understood the concept of VAR. VAR is nothing but the maximum loss at a given confidence level. We are 99% confident that the maximum loss in a single day will be 4.66 lakhs. We are 99% confident that the maximum loss will be 14.74 lakhs in 10 days. So that is what the answer is. Cool. All in all, what you have to remember is this much of the formula and one more formula, which is z is equal to x minus mu by standard deviation. And please remember, this formula of VAR is derived from this formula itself. So ultimately there are only 2 formulas. Z is equal to x minus mu by standard deviation, and standard deviation for 10 days is equal to standard deviation of 1 day into under root t. With the help of these 2 formulas, you are deriving all the other formulas. But all in all, you will have to remember only this much. This was our first question, where I have explained you the concept of VAR. We have derived the formulas for the VAR with the help of z-score formula. From the next question, we are going to solve from the next lecture, we are going to solve all the question very fast, because we are done with the risk management formulas. We are going to first revise all the formulas in the next lecture, and then we'll start with the question number 2. I hope you have understood everything. If you have any kind of a question, you can just ask me in the Telegram group. Bye bye for now.